All right, welcome back. And now we're going to talk about solving systems of linear equations using the inverse of a matrix. Okay, so now we already seen many different examples of where we have systems of linear equations and we've solved them. Now what we're going to do is we're going to use matrices to solve this. We're going to set this up as a matrix equation that we're going to solve. So before we do that, let's take this system and how would we rewrite this using matrix? Remember when we did the coefficient matrix, we did the augmented matrix, right? So the augmented matrix was written like this, right? We had the 3, -2, 1, and then we had 4. And then we had 1, 4, -1, 2. We had 2, 5, -2, 1, right? And so we've done those, right? But now, and I also said, remember that the columns represent the variables, right? But now what we're going to do is we're going to dissect this even more, because where do those variables come from? Well, implicitly in here, there's another matrix. So what we're going to do is we're going to set this up like this, right? So we're going to have the coefficient matrix, right? The coefficient matrix is going to be 3, -2, 1, 1, 4, -1, and 2, 5, -2. So this is called the coefficient matrix. Now, how do we get the x, y, and z in all these? If we were going to go backwards and we wanted to use this coefficient and redo this part right here, what would we do? Well, think about matrix multiplication. If I have another matrix here, right? And let's call this, it's a 3 by 1 matrix, and let's just put in x, y, and z. Now notice what happens here. If I take 3 times x, that gives me this one. -2 times y gives me that term. And 1 times z gives me that term, right? Boom. And then I go to the next row. 1x plus 4y minus what? 1z. And then I go to the next row. 2x plus 5y minus 2z. So the inner product, right? So if I look at the inner product, that gives me these, right? Now, this times this gives me this part, but I need the constants, right? So now what I'm going to do is I'm going to put the equals, right? So this part gives me everything on the left side of the equals. Well, what's going to be on the other side of the equals? It's just going to be another 3 by 1 matrix, which we call the constant matrix, that just has the constants. So this is the matrix of variables, right? So this is a column matrix. So we call this a column matrix. Oops. Of variables. And then this is a column matrix of constants. Okay, so this is the coefficient matrix, this is the column matrix of variables, this is the column matrix of constants. So that's how we can transform this system of equations into a matrix equation that we can now solve. Okay. Let's stop there, and in the next example I'll go even further and we'll set up the general matrix equation and how we solve it.